Today we're going to look at measures of central tendency. So if we have a large data set, how do we describe how it's behaving? Is there one number that we can look at that will give us some idea of that data set? And the simplest measure of central tendency is the mean, or the arithmetic average. So that's something that you're fairly familiar with. If we have a large data set and we're interested in examining that large data set, what do? We add up all the numbers and we divide by how many we have, and that gives us an average. So I'm going to open up Minitab, and you'll notice I've put in two sets of data. The first set of data is Chicago Bears heights, and the second set of data is Downers Grove home prices, prices that were listed on Zillow, and what the asking prices are. Now, if we wanted to get the average height for the Chicago Bears, we'd have to add up all of those numbers. How many are there? There are a total of, you can see how many there is going to be, a total of 64 numbers. And we could add those up and we could divide by 64. That's not a problem for us. We could do the same thing with the Downers Grove home prices. The computer does that for us. If we say describe C1, it gives us the average height for the Chicago Bears, 73.891. So on average, a professional football player is about 6 feet 2 inches tall. Clearly, this is higher than the average population. And let's take a look at the average selling price for a listed home in Downers Grove. So I'm going to say describe C2. And what do we get? And you will notice there that the average selling price is $389.8. $390,000 is the average selling price. But are these data sets similar? Are they different? Can we get some feel in terms of what they represent? So the mean gives us a measure of central tendency. It gives us one number that describes an entire data set. But when is the mean insufficient? When doesn't it tell us the whole story? Think about a data set where all of the numbers are basically the same. Let's say 60, 60, 60, 60, 65, and then 3,000. That 3,000 is so very different that if you would take the average of all those numbers, it is not really a good representative of central tendency. So we have to ask ourselves, are there other measures of central tendency that we can use? And the one that you may have studied before is, of course, the median. So what is the median? The simplest way to think about the median is it's the number in the middle. So if I have 5 numbers in order, the median would be the third number. If I have an even number of data points, let's say, for example, I have 10 numbers in my data set. Well, there's 5 in the first half, there are 5 in the second half. There is no number in the middle. If that's the case, what I have to do is I have to go ahead and take the average of those two numbers to find the median. Okay, so looking at our data here, we can ask ourselves the question, are the mean and the median similar? So you'll notice for the Downers Grove home prices, the mean here, 390,000, but the median is 325,000. So we have two measures of central tendency that are very different. When we went up to the Chicago Bears, we had a mean of very close to 74 inches, and we had a median of very close to 74 inches. So with respect to the heights of the Bears, the mean and the median are about the same. But with respect to the housing prices in Downers Grove, they're very different. Now, how can we get a feel for that, why that is? Let's take a look at our histogram. We can do our histogram for C1. These are the Chicago Bears salaries. And you'll notice that that data set is got a high point in the middle and it tails off to either side. So we would say this is a symmetric data set. But if we do a histogram for the sale prices, what will that look like? Histogram. C2. What does that histogram look like? You will notice it has a big outlier here at 1.6 million. The large number of values are to the left of the distribution and they gradually tail off. This is not a symmetric distribution. In fact, we call this a right skewed distribution. When you have skewed data sets, oftentimes it is better for us to look at the median rather than the mean. So can we find the median of that data set? And again, you will notice that Minitab told us for the Downers Grove prices that the median was 325,000. And I just want to go ahead and compute that by hand so that we can see it. So we're going to put the data in C3. I'm going to say sort C2, store that number in C3. It'll put those numbers in order from lowest to highest and put them in C3. So now we're going to look at the numbers in C3. So these are sorted Downers Grove home prices, just so we know what that represents. And how many numbers do we have in our data set? Let's take a look. In our Downers Grove data set, we had 30 numbers. So there's 15 in the first half of the data set. There are 15 in the second half of the data set. So if that's the case, the average of 15 and 16 should give us the median. And you'll notice we have 320 and we have 330. So based on that, it appears that the median home price is half of 320 plus 330, or 325. Of course, that represents $325,000. Now, if you want to go ahead and find the median of the first half of the data set, we would look at the first 15 numbers. 15 numbers in the first half of the data set. There would be 7 in the first half and another 7 in the second half, which would leave 8 right in the middle. So that is the median of the first half of the data set is 190. So let's quickly write up there. That's called Q1. Median of the first half of the data set is 190,000. And then if we look at the second half of the data set, what will that give me? Second half of the data set. So starting at 15, starting at 16, (16 through 22 would be the first half. That's 7 numbers, 23 through 30. Would have 8 numbers. 23, I believe, is the middle of that data set. So we're going to say Q3, which is the median of the second half of the data set, will indeed be 480. Now we're going to check to see if that agrees with Minitab. It doesn't always. Q1 is 190, Q3 is 480 is what we computed. And you will know he has Q1 is 184.5 and Q3 is 487.3. There will be minor differences between how Minitab computes these things, how a graphing calculator computes these things, and how the textbook computes these things, and how we compute these things. But they're all relatively minor differences. It has to do with how we handle that number in the middle. So again, we saw the median is the number in the middle. And we said Q1 is the median of the first half of the data set, 25th percentile. Q3 is the median of the second half of the data set. And as I mentioned earlier, there is some disagreement in how to compute these numbers. They're generally close enough to each other not for us to be too concerned about which exact strategy we're using. Now, one thing we're going to talk about are box plots. We use box plots to give us a visual representation of the spread in a data set. And the box plots use minimum, Q1, median, Q3, and the maximum. An example of a box plot are the numbers we got for the Chicago Bears data. For that data, a minimum of 67, and so 67 represents this number. 72, the median of the first half of the data, represents that number. Q3 76 is the second hinge. Median is here, 74, and the maximum is 80. So that's a nice representation of that data set. So we use those 5 points, minimum, Q1, median, Q3, and maximum, to go ahead and give us a visual representation of the spread of the data. And let's finish by looking at a box plot for the Downers Grove homes. So we'll ask Minitab to do a box plot for C2, and we'll see that representation. Notice the maximum is way up there. Minitab is actually calling that an outlier, and that is not a symmetric data set.